Hello, welcome. Good morning, good afternoon, good evening, where you are in the world. I'm sure good evening for most of the people joining from India. Thank you for taking time to attend. On behalf of All India Oracle Users Group, a very warm welcome to AIoT Weekly Webinar Series. And today, time is little different. We typically do in the lunchtime of India, but since we have speaker joining from US, so it's not really good. So that's why we changed this to evening time. Apologies for that. I'm sure most of you know about the housekeeping tasks. Please look at Q&A bottom of your screen. Please ask questions for speaker at any point of time. And today's speaker, Roger, is going to answer whenever appropriately. And also take a screenshot and thanks to speaker in, especially in Twitter or social media channels. And also we will share the presentation material and the recordings are available for gold and platinum members. And as you know, we are the voluntary organization, so sometimes it's very difficult to respond in email. So it's the quickest and easiest way to connect with us in WhatsApp and Telegram. So please if you are not in the part of the group, please join this groups. And today we have a speaker, Roger, and luckily he's also my colleague in Accenture. He's also Oracle Ace director, and as you can see, he's also did recently OCI certified GenAI professional, which is very important. If you're a DBA or a developer, I think we need to really move to the new technology. We need to get certified on generative AI certifications, very important. And also he comes with a lot of experience. I think it's almost 39 years into the techno business and also author of Dynamic Oracle Performance Analytics. I'm not sure some of you or most of you know about this book. So a lot of credentials coming with Roger, and it's lucky we have Roger today presenting on this topic. Welcome. It's morning 8 o'clock for him. So hope he had a coffee and not a breakfast, but let's give the stage to Roger and I'll come back to you on the next webinars and what's happening in AIoT after the Roger's presentation. So with that, warm welcome, Roger. Over to you.
Right. Yes. Thank you. Let me share. And as questions come in, should I just read them or will you read them out to me?
I think the best thing is continue with your presentation and I'll moderate at the last 10 minutes. Yeah. Okay.
Okay. So hopefully you can see my screen.
Perfect.
All right. Perfect. Perfect. Yeah. So this presentation is, for me, a good presentation, and thank you for inviting me to speak to you, because I do have a passion for tech and Oracle and Oracle's capabilities. And really, Oracle has a lot of generative AI capabilities and AI capabilities that have been exposed recently or maybe published. And I think a lot of the capabilities have been there for a very long time, but just not very well published. And I do have a reference, but I forgot to include it in these slides, but there is a third-party research organization that just placed among 25 vendors Oracle as #1 overall in AI. So Oracle is well positioned to be the leader in this field, if it's not already the leader in this field. But anyway, I'll get started. I'll talk a little bit about me. I'm Oracle Ace Director. I work for Enctech Group, which is part of Accenture Oracle Business Group here in the US. I live in North Carolina on the family farm. It's not green like that right now because we're starting to get into the cold season. So everything the leaves have changed colors. In my copious spare time, I also do a little bit of woodworking. So this is a American country kitchen hutch that I built out of black walnut and maple. So the dark wood is black walnut and the light wood is maple. So I've been doing this probably for 50 years, longer than I've been doing Oracle. But I started with Oracle back in 1985 as a developer at version 4. And then I did the typical progression to tech lead, project manager, application DBA, even spent some time as maybe 6 years or so as enterprise architect. Um, a lot of my experience in presentations and even the book that I have is about performance. And I worked in a group where we had 300 production Oracle instances and about 2,500 applications. So something was always broken. So it was a good environment to be in. I got to learn a lot. I presented at numerous conferences over the years, and here's a list of a few. Or actually presented at Oracle Cloud World this year, and also back in 2019. Let me see. Oh, yes. My current focus is on OCI and database architecture, and then also the generative AI capabilities and how to bring those capabilities into our consulting practice. I do have a book, as I mentioned, Dynamic Oracle Performance Analytics, and it's primarily a statistical anomaly detection mechanism, and it's written in SQL. So using standard relational SQL and statistical methods. But I guess you can say I've been about designing, building, and operating applications for performance all of my professional career. So today's, the goal of today's presentation really is to just help people cultivate an understanding of these generative AI capabilities, and then also to be able to go confidently and use these capabilities to drive innovation within your organization. So I'm going to talk about LLMs, large language models. Probably many of you already know about this. A little tiny bit about prompt engineering and retrieval augmented generation. The bulk of the presentation will be on the 23 AI vector search, and I will talk a little bit about agents in AI systems and why they're important. And then this one I thought was very interesting, so I'm just including it, generative adversarial networks. What is that? When I first found out about those, it just sparked an interest in me. So I'll talk a little bit about that. And then I'll go into the Oracle's AI, which will include generative AI as well. And I have some references for you, and then also a slide that has some skills that you should take a look at. So for large language models, some of you may have heard of this paper, Attention is All You Need. So that was written in 2017, but that's the paper that's classically referenced for describing the transformer architecture, which is what the large language models use. And really what it's about is training on large data sets. That's why they call it large language models. That's actually not a prerequisite for using the transformer architecture. A lot of people are finding out that if you have smaller models that are trained on very precise data sets of your field of interest, then you can get answers or more relevant answers more quickly with less compute resources, required. So the very large data sets are actually, those big models are compute intensive, and sometimes you get bad information from them because of just the breadth of information that they're trained on. The mechanism that, or there's a few mechanisms that tie this all together. One of them is called the self-attention mechanism, and that's really about identifying and connecting related concepts in the human language. So that's something prior to the transformer architecture was difficult to do. And then there's this concept of embeddings, and that's basically taking words or phrases, your text, and representing it as multi-dimensional vectors. And that, that numerical representation is what allows the systems to compute on very complex things. And then there's this other concept of long-range dependencies, and that's the large language models based on the transformer architecture can maintain these relationships of ideas, even if it's, they're widely spread in a document or in a, corpus of information. So just comparing generative AI and large language models quickly, the generative AI is really for multimodal creation. So that would include not just text, but it would include images and audio, those kinds of things. Whereas the large language models is specific to text generation of the human language. And so there are lots of models. I did mention the generative adversarial network, and whereas the large language models is really focused on the transformer model for text generation. So there's a broad application, so the generative AI can be used for, the art field, and really a broad range of applications. Whereas the core applications for large language models is more or less like question and answer type of applications like ChatGPT, summarization, translation, conversion, so language translation, etc., and conversation. So as you may have guessed, large language models is a subset of generative AI, which is really a subset of machine learning. And again, that's a subset of artificial intelligence. So I did list out, these are, now this slide was made about 6 months ago, and this was the large language models available in Oracle at that time. So there are more actually now, but at the top, you have, or over there on the left, you have the decoder models. And that's really for the application of, like your chat applications, and summarization, and that type of thing. And then over on the right, you have the encoder models, and the encoder models are what are used to create the embeddings, right? And that's really creating the vector. So that's sort of like another term. Vectors are called embeddings, but if you the encoder models are those models that are used to create the embeddings or the vectors. And of course, they have parameters. The large language models that normally they talk about the size of the model, and most people believe that the bigger the model, the better answer you're going to get. But it really just depends on that corpus of information that it's trained on. So, for example, the Cohere command light is only trained on 6 billion parameters, but it's actually cheaper to operate the Cohere command light model in OCI than it is to operate the larger models. And it's a pretty big difference. And I forgot exactly what that cost difference is, but it's substantial. And then when you get into the encoder models, that's has to do with some of the attributes there that are important are the vector dimensions. So in other words, how many dimensions are in the vector, and then how big of a run you can do with them. So it's just I found that interesting to sort of separate out or think about some of those key features of the different models and compare and contrast them. Prompt engineering, this is probably a topic that you've heard of, but really the importance of doing that is to craft effective prompts, because you're going to get a better responses from your large language models, better and more coherent answers. And there's going to be less trial and error interacting with the large language models if you have good prompts. And some of you may have already experienced with ChatGPT. If you put in a general question, you get maybe not the answer you were looking for. And then, of course, there is the cost optimization idea there, because you pay per token if you're paying for a model, and so the less tokens, the less money. And the token is essentially a word or a character, however they measure it. But then again, you're going to have better control and precision if you have domain-specific responses, for example. So practical example, you might say, tell me about databases. That's really lacks focus. Your responses are likely not going to be suitable. But if you're really interested in comparing RAC and DataGuard in terms of high availability and disaster recovery, that's focused more on the desired response that you want to get. And then just just an interesting opinion here, at least for me. People like large language models because when they're prompted correctly, and I put that in quotes, you get the answer that you want. And it's kind of like the confirmation bias. And I'll give you an example. In my book, I talk about taxonomies, the field of taxonomy. So I was doing some additional research on the field of taxonomies, and the web application had a generative AI engine on it. And I got back an answer that was generated by web AI, and I said, or generative AI, and I thought, now that is the best explanation of taxonomy that I've ever seen. And then when I look at the reference, it was rogercornejo.com, something that I had written and posted online. So you will get the answers that you want. And that's, in a sense, kind of a fault of generative AI, but it's also interesting. So prompting techniques, zero shot prompting. So you can ask the model to do something or to give you an answer without giving it any examples. But if you give it some examples, then you're going to get, a better answer. So you might say, okay, give me this answer in, 4 bullet points or something like that, or short bullet points, or paragraph form, things like that. The chain of thought process, or chain of thought prompting. So that's really you're asking the model to break down a solution for complex tasks into smaller steps. And people use this a lot for mathematical answers, because as it turns out, because it's large language models is dealing with text, it's not really dealing with numbers. Often you probably have heard already that you'll get weird answers, like it doesn't know that 11 is greater than 9. So it thinks that 11 is less than 9, probably because of ASCII correlating sequence or something like that. They may have fixed that, but that was a classical hallucination, I suppose you could say. And then
Roger,
role-based.
sorry to interrupt you. I think, most of our audience or DBAs, I think they
Yep.
are little struggling to follow, in terms of, I think maybe if we give more examples and a little more time on these things, that will be really great.
Uh-huh.
Um, they now, I think maybe
Okay.
most of them.
We
Hmm. Go ahead, sorry.
yeah, certainly that's fine. These slides in the beginning are maybe less duration. So
Okay,
I'll get to the 23 AI and what's in Oracle. But some of these things are just sort of basics, to understanding, what is the large language models, and they are important, if as you're building applications.
sure. Thank you.
Okay. So the retrieval augmented generation, this one is probably, definitely more related to the database, because essentially you're enhancing the generative AI models with external knowledge with the retrieval augmented generation. And what the term there is grounding. So basically you're grounding your results in domain specific context, which is important to your business. And that's going to give you reduced hallucinations and then also contextually relevant responses. And of course, typically, and certainly with Oracle, we're integrating with databases for enriched responses. So that's very important. And then you're combining that enterprise data with the large language model body of knowledge. And of course, as your enterprise data changes, then your responses will change also. So the responses are dynamic. So probably many of you know that when these models are built, they're built as of a certain date and time, and they don't know anything else new. But when you include retrieval augmented generation, now, of course, they know about new things. And essentially the way that works, you do have the precondition is having a pre-trained large language model that's trained on a massive data set. And then you have a user query. The user query is actually turned into a vector, but that goes into the retrieval model. And then from there, it searches the knowledge base. So in the context of Oracle, that would be your database, your vectors that are stored in a database. and then that's going to return relevant documents, which will go with your query. So relevant documents plus your query goes back to the large language model, and then it generates a response for your user. So that's essentially the RAG in a nutshell. As far as Oracle is concerned, the way that works is you have your user's natural language query sent to the generative AI agent, and then it sends that request to your data store, which would be your database, and that will take that query and then formulate an execution plan to search the knowledge base, rank those documents for semantic relevance to the question, and then send those documents and the original query back to the large language model, and that will send the response to the user. So that's basically how the RAG agent in Oracle works. And then the user is going to get that response that's going to be contextually relevant with the data that's vectorized in your database. So this is the meat of the presentation, the 23AI vector search. And I like to use this sort of iceberg model. So with the relational search, there may be, hidden meaning in your data, especially if you have a lot of text data or documents or other things. Whereas when you get into that semantic search on relational and unstructured data, it just opens up a whole new level of understanding of what's in your data. So the outline of this part is I'm going to talk about what is the vector search and why use the vector search, and then some basic operations and key components. And I do have a blog reference here for vector search that goes into good detail. So of course, this represents a database technology paradigm shift. We've never been able to do this before with the database, but that's now we can have semantic search applications implemented in the database. And these are familiar environments for Oracle developers. It's SQL in terms of DDL and queries and very familiar operations, although there is some new features and capabilities that you'll have to learn about. But there's a lower barrier to innovate with these new database capabilities. So I think that's important. The primary use case would be if you have relational data and unstructured data that you want to combine together with normal relational queries. And I would say, you would probably not want to use Oracle AI vector search if you didn't have any relational data. So I've seen people try to use it as a vector store, but there are other vector stores available for you if you don't have any relational data. So the way it works for this vector search, you have your files and documents or CLOBs and BLOBs, and then you run them through an embedding model, and that can be an open source or commercial embedding model. And then it creates the vectors where you can store next to the business data. So you can store it in a column right alongside your relational data. And then you can perform similarity searching, and it will return the vectors that have the most that are most similar. And then essentially you're going to get that data returned to you. So that's the basic operation. Some of the key components here, we have the vector data type, which is a new data type in 23AI, vector indexes. So that's how to make your searches faster. So comparable to indexes on regular relational data. And then there's the similarity searching and distance functions, and these kind of go hand in hand. So you can use a distance function to inform your similarity searches, how you want to do that. So of course, Oracle has had this approach of having many different types of data types that are supported in the database. And of course, blob and CLOB, they have been added, many years ago, but they weren't present in earlier versions of Oracle. XML type that was added, JSON, other data types for spatial, user-defined data types, etc. And now there's a vector data type for the multi-dimensional vector embeddings. So Oracle really is just using their consistent pattern to introduce this technology into the database. So what is a vector? We did speak on it already, and it's essentially a sequence of numbers that defines a point in multi-dimensional space. But each number, and they're also known as dimensions, they reflect specific features or attributes about the data or the item that the vector represents. So so a 24, 1024 dimension vector is a list of 1024 numbers. Now there is this idea of the curse of dimensionality. You might think that if you have a lot more dimensions, that it's going to make your results better, but that's not necessarily true. They do add detail, but it could make an analysis or interpretation harder. So that's just something to be aware of. So large number of dimensions isn't always better. So the vector data type, what is that? And essentially you just, it goes in your create table statement. So now I'm just using this data type vector, and there are a few optional parameters for the dimension count and dimension format. And you don't have to use those. So over here on the right is the smaller version of that. I'm just taking the defaults when I say vector as my data type. And okay, I think I got some slides out of sequence, but I'll go ahead anyway. So when we talk about vector indexes, there are two new indexes for vectors, and you could probably think of this as maybe like the difference between bit mapped index and regular indexes or Oracle or reverse key indexes. So there are new indexes. You do need to understand something about them. The first one is an in-memory index, and really that one's optimized for very fast searches, but it really relies on you being able to fit that index into memory. The other index type is an inverted flat file. It's for very large data sets, you would want to use that. So you do need to understand a little bit about these. Oracle has documentation on that, but I also have a reference here from this source here, which explains the complexity of what is a hierarchical navigable small world index. But typically you don't need to know the details there, but just know when to use it and when not to use it. So I did, put this comparison table that helped me understand, and then also help others understand, for this index type, what are its qualities, when I want to use it and when not to use it. So again, the in-memory network, in-memory neighbor graph vector index, that one you want to use when you have lots of memory and you can fit that index in memory. The other one, the inverted flat file index, if you have limited memory or very large data sets, you would want to use that one. And I guess that's vice versa, when not to use. So hopefully that comparison chart will help you understand when to use these index types. There are some memory considerations. So there is a memory pool set up for the vector indexes. So it will store the indexes and the metadata. And there is a new parameter, vector memory size parameter, and you can actually query a $V vector memory pool if you want to see what's, how that's set up. There is, Oracle gives this calculation to how to use these HNSW indexes and how to establish the right amount of memory for it. So it's 1.3 times the format size. So that was that float 32 thing that you saw, times the number of dimensions times the number of rows. And that will give you the account for the overhead required for that index. So there's an example calculation for you. So one of these indexes with 1 million vectors and 1536 dimensions in float 32 is about 1.9 gigabytes of memory. The IVF indexes, they leverage the buffer cache and disk storage, so they're suitable for large data sets. So just a few memory considerations. There are other parameters associated with the vectors, but I do have a reference to the documentation where they're called out. Some new views. So Oracle has now introduced new views so that you can understand what's in your vector indexes. So the first one, VecSys, I guess that's the owner, vector dollar index, that gives you detailed information about your vector indexes. We can get diagnostic information about the vector indexes from $VDollar vector index. And then if I want to get diagnostics about the in-memory neighbor graph indexes, that's the $VDollar view for that. And then also for the inverted flat file index, they have another $VDollar view there. And then for your own specific index, that you can get details on that, and that's the index name dollar vectors, and that will tell you about how it's some details about how it's set up, the index for each document. And the reference here is the AI Vector Search Users Guide that Oracle put out. So there, it has it's a very long document, but so these are, I'm just calling out a few things that I think you'll find interesting. So there are some restrictions and best practices. So all the vectors in an indexed column, they have to have the same number of dimensions. So you can't just put rows with different number of vectors with different numbers of dimensions in each row. So you have to do that. And then you can only have a single index type per column. So you have to pick either the GenSW index or the IVF index. So that's another restriction. And then in the rec environments, there's a restriction there as well. And I'll just leave that one for reference. But you need to know these restrictions and best practices as well. When it gets to similarity searching, there's exact similarity search. And that basically it calculates a difference between the query vectors and all other vectors, but it's going to take longer to get your results. So exact similarity search, more accurate, but longer search times. The approximate similarity searches, you're going to be sacrificing some precision, but you'll get faster results. And then the other one is the multi-vector similarity searches. In a sense, it's going to just another way of searching across multiple vector chunks and document sections. So a few things to consider there. This I'll leave as a reference as well, but it's the comparing and contrasting the different types of similarity searching, exact, approximate, and multi-vector, and then when to use them and when not to use them. So when I use the vector distance function, really it's just we do have this vector distance function that Oracle has created, and then I give it 2 vectors and then an optional distance metric. And so that would be the distance or the type of searching, or whether that's cosine, Euclidean squared. I'll get to that in the next slide or two. But that's going to tell you how similar those 2 vectors are. And really, again, the vector is either like your question or what's in the database, that type of thing. So what that would look like in a single select statement. Now here's where the power is opened up, right? And this is really just a very brief example, but you have normal, ordinary relational part of your query, in the where clause here. And then we have, I'm having this order by, and I'm saying return me the most similar answers to that, and give me the first 10 rows. So this is where you're combining your relational query with your vector query. They have distance functions, and this is really, you can put that in your similarity search, which distance function you want to use, and really these have to do with the accuracy of the results. So they're and these all they come from the field of generative AI. So so Oracle isn't really inventing Euclidean distance. That's basically part of the field of generative AI, but they're implementing these techniques so that you can get the kinds of answers that your people who use generative AI for applications are familiar with. So Euclidean distance, that's essentially a straight line distance between 2 points. Euclidean squared, they're faster to compute, but it's also another way of doing it. The Manhattan distance, that's essentially measuring the distance between 2 points in a grid, sort of like navigating grids on a city street. The other distance functions you'll hear a lot about: cosine distance, and that's essentially the angle between two vectors. So that's considered a fast search as well. And then these other two, Hamming distance and dot product, I won't go into great detail on these, but you need to be aware of that these distance functions are there, and then how to use them. And I do, again, have a table here which talks about the strengths and weaknesses of the distance functions. So that's important to understand, how these work together, and when to use one versus the other. And the same thing for the cosine and Hamming similarity and dot product distance functions. One way to think about these distance functions, or in the 2D list, so if you're thinking two-dimensional vector, this is one way to think about the distance functions. So cosine is the angle between two vectors. So that would be the green vectors. And then the Euclidean would be a straight line distance between those two vectors. That's the blue line. And then the Manhattan distance, that's the distance between vectors based on the grid-like path. So that's sort of the nutshell on distance functions. I did say I was going to talk about agents in generative AI systems, but do you think I should pause for any questions?
Yeah, I think there are a couple of questions. Maybe let me read this questions. So one of the question from Tina is, what's the difference between encoder and decoder LLMs?
Okay, so the encoder that's the LLM that you're going to use to generate your vectors, right? So it's going to encode your text into a vector. And then the decoder, that's the kind of model that you're going to use to generate new text. Or so that would be so when you're building the in 23 AI, when you're putting a vector in your database, you use one of these encoder models, and then you load that encoder model into the database, and then use another function to actually vectorize your data. So the use case for the decoders is essentially like ChatGPT, or text generation, or language translation, text summarization, those kinds of things.
Okay. Yeah, the other questions are more on, trying to, I think the initial slides, the team is trying to understand a little deeper, and they are not able to follow. I think those questions
Mhm.
are um, maybe I think.
Good. Yeah, that's good. That's good.
Hmm,
That's good feedback, and I should probably have teed that off a little bit better, because but they are introductory types of things, in the field, and I think it's helpful to have that sort of basis. Even if you take the Oracle generative AI professional training course, they probably spend a good third of the class on that material, that type of material. So
okay,
it's definitely relevant to the field.
got it. Yeah, let's proceed, Roger, on the next
All right.
slides.
Yep, good. Yeah, this is a good pause, uh, but I'll go on. So agents, what are agents all about? Really, you may have heard this term and or maybe have not, but really it's about automating tasks and then also supporting decision making and then uh, having complex workflows that you can orchestrate. Retrieval augmentative generation, that's also a kind of agent, the way it's implemented. And typically in applications, they will use this for error handling and monitoring. So you may have heard that um, generative AI applications are not very good at numerically intensive applications. Um, and people have built agents or added agents to their workflows to correct those mistakes. So in other words, if you know that your answer needs to have correct data in a certain spot, then you'll have an agent that will read the response from the LLM and make sure that the right data is in the right spot for the answer. Um, so that's an interesting way of correcting those problems. And then, of course, integrating with business applications. Um, so the general way that or framework for agents is you have multiple independent agents, and each agent has a specific task, and they interact with one another. But essentially, it's giving you that capability to have more sophisticated workflows and get better responses from your generative AI. And so that's essentially the basic framework for that. Let's see what the yeah. Any questions on the agent framework? It's definitely a very big field in generative AI, and it's the place where a lot of people are investing. So, for example, our company, we have these agents sort of pre-built. You could think of them as modular solutions, right? And then you're able to uh, piece together with multiple modular solutions, another solution in a different use case. So agents are going to be very important. And you'll see most of the big generative AI applications are based on this agent framework. Okay, so the next thing, the generative adversarial networks, I found this really interesting. Essentially, there are two neural networks involved. You have a generator and a discriminator, and they work together. But so the generator will create some synthetic data, and the discriminator will try to evaluate and see whether that data is real or not, and they work together. They compete, and you can call it a game where the generator tries to fool the discriminator, but they learn from their mistakes and they're able to make corrections. And the use cases here are generating synthetic data. So a lot of you see that a lot in the healthcare field, clinical trials. If you want to understand a population of humans and their medical conditions, et cetera, et cetera. It's hard to get that information unless you're actually conducting and collecting the data from real people. Whereas if you can generate synthetic data, then you can possibly get some answers to your clinical trials without even having to conduct them. That's the idea there. Anyway, but they also use that to generate music and images. And then also you may have heard this term deep fakes. That deep fakes uses that generative adversarial network technology. And the way it works is, again, I said you had the generator, and it gets random input, and it sends that to the discriminator. Now the discriminator knows what real images look like, and then they take and they back propagate the errors, and they use that to learn and by adjusting their weights and so forth. It's very interesting. So both the generator and the discriminator will back propagate their errors, and until you get a good, decent image or deep fake or synthetic data. The Oracle's AI stack. Now this one I found quite interesting. So this is the published AI stack from Oracle. The very few things here are just right straight in the database. So you have Oracle database vector search, that's in the database, right? And the autonomous database has the select AI capability. I'll talk a little bit about that. But the rest of these capabilities are essentially in OCI, so serviced out of Oracle Cloud Infrastructure. The Select AI, if you have not heard of that one yet, basically you're posing an English language question. You type in Select AI space, and then you give it a quoted string, which is your question, and then Oracle will generate the SQL statement for that, run it, and show you the answer. And it'll also show you the SQL statement that it generated. So Select AI, I think it's a very good thing, maybe for exploratory, if you had data scientists who didn't necessarily know what's in the database, for example, they could use Select AI capability to get some data and then take a look at the query and find out if it's seems like it's something that they want to permanently make part of their application. And of course, we did talk a lot about vector search. So these capabilities that are highlighted in gray are the generative AI capabilities. So you have the GenAI and GenAI agents, Code Assist. There's a lot of work that's been done and spoke about Oracle Cloud World in that area of Code Assist for developers. Some of these other capabilities like speech, language, vision, document understanding, machine learning in the database, that's been available for many years. So these are, AI capabilities, not in the generative AI category. And then, of course, Oracle is embedding AI in their applications and then the industry applications. So you might find things like they're in hospitality, the hospitality industry, applications for that, and then also utilities, many other vertical industry applications. And then there's third-party applications. So a lot of interesting things going on there where third-party applications are available inside of Oracle. And then, of course, they're undergirding this with their AI infrastructure. So having those RDMA superclusters with NVIDIA chips, and then also super fast network, that's very, very important. And then a lot of capabilities around compute with GPUs, and then also your objects storage. One thing though that so I did tell you that I was interested in taxonomies. So I built a taxonomy to organize these vast OCI AI capabilities. So the those few at the top that are in the sort of light green, those are covered reasonably well in the tech stack diagram. But there's also a lot of other capabilities that ultimately you will need to know about, at least some of them, for generative development, third-party tools. How do I use third-party tools to build these applications? And then also DevOps, and then you can't forget logging and monitoring and security. So those other things not spoken about in the tech stack are still important. and they're really essential for your end-to-end solution. So you're going to need to dig deeper into the docs to find out what those are. But I've done a little bit of digging here, and so for, let's say, for a specific use case, I'm not going to need everything in the tech stack, right? So this is where you put on your architecture hat and figure out which services or capabilities in Oracle am I going to use for this application. So in this application, let's say I'm going to use the OCI generative AI and the vector data type and the Cohere command model. But then I'm also going to need block storage, object storage, and API gateway, so forth and so on. So that's just typical OCI technology for your end-to-end solutions. And then I've gone through and I've cataloged the capabilities. Now this is not exhaustive, but at the top, you may remember at the top of the AI tech stack, they had applications, Fusion applications and Fusion analytics. They didn't mention anything about third-party applications, but Palantir Foundry is a very interesting third-party application that's in the generative AI capability, and then also NVIDIA AI Enterprise. So NVIDIA has partnership with Oracle, and they have built, lots and lots of applications and agents for generative AI, and those are, I guess, would fall into that category. And then I have your industry applications as well. So if you have or Oracle has embedded AI into those. So I'll quickly just go through these because they're really here just for reference. But in the large language models, there are a lot of things here of interest. This one, Cohere command, that one should be in green. Well, actually, none of these models were represented in the Oracle AI tech stack, but they are available. So it's helpful to understand what the catalog of capabilities is in the Oracle AI stack. AI and machine learning services, they did a good job of representing these in the tech stack catalog or their tech stack, but really not that much in the sort of normal OCI services and capabilities that you will need. But these are just some of the capabilities that are sort of adjacent to and necessary for, or maybe necessary for deploying your end-to-end solutions. And of course, generative AI. There was GenDev was spoken about at Oracle Cloud World. So I think there's going to be a lot here for people to understand about AI Assist and Apex GenDev and so forth for how Oracle has made using generative AI to make development easier. And then, of course, to build AI applications, you need things like LangChain, Langsmith, and so forth, Python. So these are all you won't necessarily need all of these, but certainly Python and LangChain and Langsmith are going to be top on your list. And then, of course, you have the DevOps things as well that are important. And your storage. So that was the sort of the bulk of the presentation. I do have some references here. Provide a reference to the attention is all you need. I have a lot of posts on my blog regarding generative AI. I call it the GenAI Demystified, but semantic understanding and reasoning. So what's that all about? RDMA superclusters. What is this one all about? 23 AI vector search, I already mentioned that one. The limitations of large language models, and I did mention that they're not very good for numerically intensive applications. And then also some just maybe like a lighter post on bias in generative AI. This paper was actually accepted in Oracle magazine, Oracle World magazine, and interesting article about how database professionals and generative AI professionals can work together in building these applications and really in a team effort. And then, of course, a link here for the generative adversarial networks. As far as skills, definitely, I would say go to the Oracle AI Solutions Hub. There's a lot of there where certain applications are built out. Generative AI applications are built out. Um, the My Learning, Oracle My Learn for Oracle Cloud Infrastructure AI Foundations. That one's a certification, so that's good. And I probably should have listed here, there is also a 23 AI vector search course. It's not a certification, but it is a course that's available to you. And that was the end of the presentation. So I'll take any further questions if you have them.
Yeah. I don't know. I didn't see any question. I think I can summarize. Basically, most of the people are from the DBA background. Maybe it is a first session to digest all the information is too much. Maybe I think Roger actually consolidated a lot of good information in this deck, right? I think we can use this deck as an index for our learning, right? And maybe I think in a few months' time we have a more detailed session on this. Is that correct, guys? Or maybe you can respond in a chat or Q&A, yes or no. Can you guys respond in? Yeah. So Milan says yes. Can I get some more yeses or no? Okay. Yeah, thanks for that. I understand the pain, right? Because sometimes if you see some new technologies and it's very challenging to understand. But I think Roger actually spent a lot of time to get these things at least in a good presentation, right? So and also we know the contact now, so that we can definitely reach out to Roger for another session, right?
Yep. Yeah. If you had Sean Stacy on, because he has a really good presentation on the 23 AI vector search, and he goes into the great detail of how this similarity searching works and stuff like that.
Yeah, exactly. So let's do this. I'll also try to get other speaker into this call, whenever we have time. First of all, thank you so much for joining, Roger, in the early morning your time, and also thanks to my attendees because typically they attend in the afternoon. I think this is the first time I'm testing in the evening, especially these days. So thank you so much for both sides. And also, if you look at the next slide, I think we have more sessions coming. I think you'll see AI is in everywhere. So everybody is using AI in their titles. So please make sure that you register and share with your connections. I think another important good news is, sorry, I just jumped on two slides. We have multi-cloud world coming in 4 cities in Feb. We are trying to, in conjunction with the Oracle Cloud Tour, Mumbai is happening on 6th of February. I'm not sure how many of you know. So we will do this first 2 weekends. So first two Saturday, Sunday, and the second Saturday, Sunday. So we'll have, almost 5 cities covered. So please make sure that, you come to this session and also bring more people, so that way I think we'll be very successful in this. So with that, thank you so much again. Have a nice evening, Roger. Have a nice day. Thank you so much for spending time with
Yes.
us. Bye for now.
Mhm. You're welcome. Have a good day. Bye.
Bye.
Bye-bye.